Chapter 1 Introduction Getting Results. After being critical in the foreword of oversimplification of complex systems, I will immediately launch into a simplified modeling of something highly complex. This is a common practice in science and engineering in order to be able to take a complex problem and at least reduce it to something complicated and make design decisions. The skilled engineer or scientist makes the right simplifying assumptions and is aware of the limitations and dangers inherent in those assumptions and when the model will break down. The starting point for this discussion is the starting point of why organizations exist. An answer is to achieve a desired result. See Appendix 2 for a more process-centric framing. From a high-level organizational perspective, the desired result is expressed in a mission statement. Organizations that lose sight of their desired result will inevitably drift off course and risk becoming corrupted distortions of what they were meant to be and do. Where do results come from? Actions. Figure 1. Actions and results. The ends, results, do not justify the means, actions. The journey to a destination is at least as important as the destination. Leadership defines not only the destination, but also the journey. Good leadership is about guiding the organization's actions in a principled and ethical way to achieve the desired results. Quoting Peter Drucker, only 3 things happen naturally in organizations: friction, confusion, and underperformance. Everything else requires leadership. Shifting gears to an engineer's analysis, what factors determine whether the results achieved are as desired? Certainly there are outside influences, but the ones under a leader's control are 1. Competency of the actors, C. 2. Amount of action, A. 3. Coherence and quality of action taken, Q. These combine in a multiplicative fashion. Meaningfulness of results is proportional to C times A times Q. By meaningfulness of result, we mean how close to the desired result we actually get. If any of C or A or Q drop to 0, then the overall meaningfulness of the result drops to 0. A good example is in the kitchen, where we have a desired result of a delicious meal. If you put someone with no culinary competency, C, but loads of energy who will work very hard, A, and good ingredients with a proven recipe, Q, the results are still likely to be poor. If you take a great chef that is totally burnt out and incapable of putting in the full effort, even with a good recipe and ingredients, the result will be poor. If you have a great chef who has the energy to work, will put in the work, but has lousy ingredients and a lousy recipe, the result will be mediocre at best. If you have a great energized chef, a great recipe with ingredients and equipment, we will now get the delicious meal we are aiming at. In the above example, there is coherence needed between the recipe and the ingredients. A great recipe, but with missing ingredients, is incoherent. Often, a single missing ingredient is enough to significantly reduce the quality of the result. Visually, we can look at the above as follows. Figure 2. Components of action. Energy is a subject that will come up again and again in this handbook. Setting conditions that will create a resonance and increasing energy level in the organization is one of the key roles of the leader. This is more than the commonly described simple motivation. A key part of raising energy levels is in the provision of an overall coherence to the organization. In this book, we will use coherence broadly to include the quality of action, but it's much bigger than just quality of action, and to limit the definition to quality of action is too much of a simplification. While positive resonance and energy lift is a desired outcome of effective leadership, alertness is needed from leaders at all levels to the opposite: negative resonances and decreased energy. Underlying almost everything a leader does is communication, transmission and receiving of information. A great leader must be a great communicator. This is axiomatically and critically true. While there will not be a section devoted to communication in this work, some aspects will be emphasized here and there. However, communication alone does not make a great leader. It may even be able to create a simulacrum of a leader that is in reality a fraud. Effective leadership requires bringing together multiple other competencies in addition to communication. With great communication of great strategy and great culture and actions that align, a sense of coherence is established. This is of foundational importance. A foundation is provided where people feel secure, their feet are on steady ground. Another great Peter Drucker quote: "The most important thing in communication is hearing what isn't said." Communication is a two-way street where a lot more than 50% for the leader is listening and hearing what is said and not said. A leader should never be only in transmission mode, but rather always be transmitting and receiving. When a leader is transmitting communication, there should be questions. If there aren't questions being asked by the team, this is almost certainly a very bad sign, and the leader should be paying attention to what is not said vis-a-vis the lack of questions. Are people afraid to ask? Are they so disengaged that they don't care enough to ask? Do they not understand what was communicated well enough to ask any questions? An essential companion handbook to this work is The Unwritten Laws of Engineering that all leaders would do well to review. The body of this handbook will cover the how-to aspects of achieving high-quality planned actions, developing highly competent people carrying out the actions, and high volume and capacity of action. Appendix 1 and 3 will provide theoretical models of generative aligned action and a burnout leading indicator. The how-tos are essentially how to lead in a way that achieves the desired results while generating aligned coherent action, generating competency, generating and regenerating capacity. 1.1. Second-order results and beyond. It is also worthwhile for leaders to look beyond the first-order direct results their organization is working towards. Achieving a particular result could lead to second or third-order results, and this is one of the most dangerous aspects of human beings' almost reckless and rapid adoption of new technologies without thinking of higher-order results. For example, the adoption of the internal combustion engine, while liberating, resulted in a number of higher-order consequences. The use of leaded gasoline and the consequent lead poisoning of several generations of humans. The anti-human design of North and South American cities centered on the automobile instead of the human experience. This, in part, explains the rise in obesity due to increasingly sedentary lifestyles. Farming in the more distant past resulted in an extraordinary fitness level because it was a highly physical occupation. Modern rural farming living puts people at higher likelihood of obesity than the modern urban counterparts. Certainly, there were positive effects as well. With longer range thinking beyond just immediate results, some of these negative effects can be mitigated. We have been exhorted by leaders who are not connected with the reality to move at the speed of science and to be data-driven. Science and technology are two very different things. Human beings adopted the technology of fire tens or hundreds of thousands of years before there was even the remotest scientific understanding. There are multiple examples in our history where we have done so to our regret in addition to the internal combustion engine. There is the prophylactic use of antibiotics in agriculture and the consequent rise of antibiotic-resistant bacteria. The use of Roundup-ready corn crops and the rise of resistant superweeds. The use of neonicotinoid crop pesticides, obliterating desired insect life, including pollinators and soil-dwelling insects necessary to have a healthy soil ecosystem. The use of industrial fertilizers, enabling the breaking of cycles of crop rotation and fallow period to ensure healthy soil. As the power of technology increases, leaders need to be more visionary and far-sighted in attempting to see beyond the immediate desired results to make better decisions on what results they will aim for. This does not argue against the adoption of technology. but rather to do so carefully and reversibly, as eloquently argued in A Hunter-Gatherer's Guide to the 21st Century. We don't need data-driven science. Real science is hypothesis-driven.